Thank you very much. Let's have a lesson on equations of motion. How do you derive equations of motion? And there are important things that you have to know as well as motions are concerned. All those things we need to know today. So keep on watching me and you know a lot of things about motion. And not only motion, mechanics as a topic and other topics in mathematics. Now, what's the relationship between acceleration, displacement, and velocity? You know, they are all vector quantities. They are related in one way or the other. And this relationship between them, I'll make them known to you. So, you know, acceleration is given as change in velocity with respect to time. That's dv dt. That change in velocity with respect to time gives acceleration. So if I multiply through dt, I will get dv is equal to a dt. Now, I integrate both sides. If you integrate dv, you get v. And the v is the velocity, which is equal to integral of acceleration dt. With respect to time, you integrate a with respect to time, then you get velocity. Because acceleration is changing velocity with respect to time. And if you multiply through by dt, this you finally arrive at this, because if you integrate dv, you get v. Now, you are integrating because dt, you are integrating a with respect to t. So v is equal to at plus c. Plus c, because this is indefinite integral. So this c is arbitrary constant. And now, what is very important here for us to understand is that as t is equal to 0, what will be the value of c? But initially, when there's no movement, if there's no movement, then time doesn't count. When acceleration is 0, when a is equal to 0, then t also becomes 0. When there's no acceleration, time does not count. Then t becomes 0 when e is equal to 0. In that case, we can have c is equal to v. Then we have c is equal to v. But one significant thing that a student of mathematics must know is that at what circumstance when the final velocity equals to initial velocity? It is when acceleration is 0. And also, when the net force acting on an object is also 0, then final velocity will be equal to initial velocity. For example, if you have F is equal to mass times acceleration, and they said F is equal to mass, acceleration change in velocity, u minus v over t. No, final velocity minus initial velocity, v minus u over t. So if the net force is 0, 0 is equal to m multiply v minus u over t. Then you multiply 2 by t. T times 0 will give you 0. So you have 0 is equal to m multiply v minus u. Then you divide 2 by m. 0 divided by m will give us 0. So we get 0 is equal to v minus u. Then I bring the negative u to this side, we get v is equal to u. So in this case, the circumstances where final velocity equals to initial velocity is when the net force acting on an object is 0. And also when acceleration is also 0. The third one is also when an object is moving with constant velocity, because there is no change in velocity. The initial velocity is equal to the final velocity, because there is no change. So when a body is moving with constant velocity, then initial velocity will be equal to the final velocity. And in this case, since acceleration is 0, then the v will be equal to u. So v is equal to u since acceleration is 0. So in this case, this one c is equal to v, and also v is equal to u. So meaning that c is also equal to u, but v is equal to u, and c is equal to v. So it implies u is equal to c. So in that case, I will get v is equal to at plus u. Because the c, the arbitrary constant is now u. So rearranging it. This one is v is equal to u plus 80. And let's make this one equation 1. This is the first equation of motion. This is the first equation of motion. Now, another thing to also consider is that velocity is changing displacement with respect to time. V is equal to ds dt, changing displacement with respect to time. So multiplied by dt, we get v is equal to, we get v dt, v dt is equal to ds. So we integrate both sides. If you integrate both sides, if you integrate ds, it will give you s, that's the distance, s. S is equal to integral of v dt. And what is the v? That's the velocity. Integral of velocity, and velocity is u plus 80. So s is equal to integral of u plus 80 dt. Now, we are integrating this with respect to t. So in that case, we get s is equal to ut plus half 80 squared plus c, the arbitrary constant. Now, having integrated this, initially when there is no movement, distance is 0, s is equal to 0. It means time also becomes 0. But when there is no movement, now if you put t here to be 0, the whole of this one will be 0, s will go 0, then c also becomes 0. In that case, the whole formula will reduce to s is equal to ut plus half 80 squared. That is the second equation of Newton. Now, having gotten this, let's proceed. So, from equation 1, we can make t decided from this. So in this case, t is equal to v minus u over a into equation, this one is equation 2, into equation 2. So I'm substituting t is equal to v minus u over